In this video, we'll talk about one-sided limits. So what's a one-sided limit? Well, the idea of a one-sided limit is that I'm going to approach a certain value, but I only care what happens on one side of that number, not both. For instance, I only care what's happening to the left of C or to the right of C. So as an example of this, if you look at our function before that had jumps, take our normal step function here, this limit did not exist, but both the left and right hand limits do exist, because if I only care about coming from the right side of 0, then on the right side, I'm always 1. And so that limit exists and equals 1. And similarly, from the left side, I'm always 0, so that limit exists and equals 0. In terms of notation for this function, we would write that the limit as x approaches 0 from the left of this function f of x equals 0, and the limit as x approaches 0 from the right of this function f of x equals 0. The minus here indicates we're coming into 0 from the minus side, so from the left as we approach that point, and the plus indicates we're coming from the right or from the positive side towards 0. So these are called left and right hand limit respectively because we're coming from the left or right side of the point. The negative sign here is the left hand limit at 0, and the plus sign here is the right hand limit. The basic point of this is it takes care of our jump issue. Let's just still talk about what's happening to a function. Even if it has a jump, we can still say the left hand limit or the right hand limit exist independent of whether or not there's a jump at that value. And this idea sort of leads us to a theorem about these one-sided limits. And the theorem says the following. It says, let f be a function defined near a point C. Then the limit as x approaches C of f of x equals some number L. And this here is the full limit. This is the case if and only if both the left and right hand limits equal that same value L. And there are a couple ways to think about this theorem and what it actually means, because that if and only if there is really math terminology. Well, let's go into what this actually is talking about. So this theorem says that a full limit exists if and only if both of the one-side limits exist and are equal. So a limit exists if and only if both one-sided limits exist and are equal. So if these two numbers do not match, this limit does not exist. And this theorem, as an if and only if, works both ways. So it says both, if these two limits are the same, then I am guaranteed that my two-sided or full limit exists and is that number. But it also means that if I know that this limit exists, I am then guaranteed that both of the one-sided limits exist and are both equal to that same number. So if the full limit exists, then both one-sided limits must match that value. Those are all our facts that we get from this theorem. The main idea is a one-sided limit means I'm only coming in from one side of the value, which means it's easier for it to exist and not worried about both sides at the same time. But we also have this theorem that says if I know nice things about the one-sided limits on both sides of a point, then I know something else about the full limit. And so this is a nice property to have when trying to talk about limits in general, because if you say things about one-sided limits, you might be able to put them together to get something about the full limit at the end.